All right, let's dive right into this explainer. We're kicking off part 1 of our system design preparation series by tackling the absolute bedrock of modern SaaS architecture, the multi-tenant database and storage layer. If you're gearing up for a senior engineering role, or honestly, if you just want to know how massive platforms like Salesforce or Adobe actually operate under the hood, this is exactly where it all begins.
Just imagine the absolute chaos of mixing enterprise data. One tiny, overlooked bug, and suddenly Company A can see Company B's highly confidential financial assets. It is a literal system design nightmare. So today, we're going to systematically solve this storage and isolation problem. We'll be using frameworks and architectural boundaries that will make your system secure, scalable, and totally interview-ready. So here's our roadmap for today. We'll quickly cover the multi-tenancy architecture, securing the tenant context, designing the storage layer, scaling databases and caches, and finally, those tricky trade-offs between shared and dedicated setups. Let's get to it.
Starting off with Section 1, the multi-tenancy architecture.
Okay, so what is a tenant? Well, it could be an enterprise customer, a specific organization, a workspace, or even a business unit. Multi-tenancy is basically how we solve the recurring headache of serving all these different entities from one shared platform, while, and this is absolutely crucial, keeping their data, quotas, and configurations strictly isolated. The golden rule here? Every single request, record, and storage path has to be tenant-aware. It's a cross-cutting concern that touches literally everything.
And this brilliantly illustrates why we separate these concerns right out of the gate. Notice how the heavy lifting for tenant handling happens way over to the left, long before a request ever sniffs the core domain services on the right. We've got an API gateway, a tenant resolver, and a Quota service acting as a bouncer. Keeping this logic completely out of your individual microservices drastically shrinks your surface area for security mistakes. The domain service just receives a neat, pre-verified package.
Moving into Section 2, securing the tenant context.
Let's actually trace a request here. The client sends a payload. Boom, the token is validated. Then, the tenant resolver grabs those identity claims and figures out the canonical tenant. It builds this trusted tenant context, checks the quotas, and evaluates permissions. All of this happens at the edge. You're basically building a fortified perimeter before anything ever touches your database.
Here is a massive takeaway, and honestly, a stance you absolutely need to take in any system design interview. Never, ever let your domain services blindly trust a tenant ID floating around in a random JSON payload. Seriously. A classic, terrifying security bug is when a bad actor just swaps the tenant ID in their API request to peek at someone else's data. By resolving it securely at the edge from a token, you literally eliminate that whole attack vector.
So instead of raw, untrusted data, you hand off this fully verified tenant context object downstream. We're talking tenant ID, org ID, workspace ID, user ID, their region, their plan type, the whole shebang. Think of this trusted object as your mandatory golden thread. It weaves through every downstream service, every single database read, and every write.
All right, Section 3, designing the storage layer.
Now, an immediate red flag in an interview is querying a database by an asset ID alone. If your domain service just blindly says, hey, get me asset 789, you are practically begging for cross-tenant data leaks. Your relational databases must always, unconditionally include a where tenant_ID clause. Make your primary key a composite of the tenant ID and the asset ID. This is completely non-negotiable if you want strict isolation. And hey, this doesn't just stop at SQL. Whether we're talking about your relational schema, your S3 bucket paths for large files, or your Redis cache keys, that tenant boundary has to be hard-coded into the storage layer's DNA. Take cache keys, for example. Formatting it as tenant ID, asset ID, builds a literal fence around that data. If you only cache by asset ID, it's only a matter of time before Company A sees Company B's cache data. Encode that boundary everywhere.
Next up, Section 4, scaling databases and caches. How do we actually handle growth, especially when one noisy tenant decides to hog all the shared resources? This table right here, consider this your ultimate interview cheat sheet for partitioning. You've got to match your strategy to the exact size and compliance needs of the customer. A shared DB with a tenant ID column is super cost-efficient and perfect for a ton of smaller tenants. A dedicated schema gives you a nice medium level of isolation. But a fully dedicated database? That's your VIP lane, reserved for massive, highly regulated enterprise clients who demand strict physical isolation and custom backups.
But look, it's not just the database we need to worry about. You have to actively protect your queues and caches too.
Think about it. You absolutely need per-tenant concurrency limits and cache size caps. Otherwise, one giant enterprise running a massive midnight batch job is going to completely starve your smaller clients of compute or just evict all their data right out of the cache. Every single layer has to defend its resources on a per-tenant basis.
Finally, Section 5, trade-offs between shared and dedicated setups.
When you weigh a shared database against a dedicated one, you immediately hit this friction between operational cost efficiency and strict compliance isolation. Option 1, the shared DB. It's cheap and schema migrations are a breeze, but you run the risk of noisy neighbors and bugs leaking data. Option 2, dedicated databases. You get bulletproof isolation and custom scaling, but your cloud bill is going to skyrocket, and running migrations across 1,000 different databases, total operational nightmare. So how do you nail this in an interview? Confidently pitch the hybrid model. This proves you actually understand how massive enterprise SaaS platforms operate in the real world. You pack your thousands of small businesses into the shared database to optimize costs. But when a Fortune 500 client signs a huge contract and demands strict compliance, you seamlessly route them to their own dedicated database or even a dedicated geographic region.
This quote nails the perfect architectural mindset. Start simple to get to market and keep operations sane. But, and this is the key, you cleanly separate your domain logic from your storage routing early on. Because you're passing that trusted tenant context we talked about, your core application code literally doesn't care if a tenant lives in the shared table or a massive dedicated cluster. The platform just invisibly handles the routing for you.
Which brings us to a final thought for you to chew on as we wrap up this explainer. Take a hard look at the system you're building right now. If a massive enterprise client walked in tomorrow and flat out demanded a fully isolated database for regulatory compliance, would your domain APIs actually survive that migration without a total rewrite? If you stick to the multi-tenant blueprints we laid out today, the answer is an easy yes. Keep building, keep designing, and we'll catch you in the next explainer.